Hello all. In today's session, we will start with the second topic, that is CNN architecture. In the previous session, we have studied how MLPs are used for classification of images. We also have gone through the drawbacks of using MLP for image classification. So to avoid those drawbacks, that is spatial feature loss and increased parameters, a specially designed neural network was introduced, which we have talked about in the previous session, called as convolutional neural networks. So I can consider this CNN as a new way of processing two-dimensional data where the two-dimensional information will not be lost. That is, I can say that CNN will accept the full image matrix as input, which will help the network significantly to understand the patterns which are contained in the image in the form of pixels. So let us start with the architecture. Before moving on to the architecture, I'll just give a statement that the architecture of CNN is same as that of MLP. That is, I have neurons which are stacked one over the other in the hidden layers. Random weights are being initialized. These weights and biases are learned. Output is generated. Error is calculated. If the error is high, I'll backpropagate through the hidden layers to update these weights and biases to reduce the error. So this process is same as in MLP is same in CNN architecture also. The only difference is in CNN architecture we don't make use of fully connected layers. Instead we make use of locally connected layers that we will understand when we move on to the next topics. So let us have an overall conceptual understanding of how these neural network functions and how different components interact to achieve the desired outcomes. Let us look into this computer vision pipeline process, which we have already done. We have input data, we have pre-processing, feature extraction and machine learning model. Before the development of deep learning, this step of feature extraction was done manually and some machine learning algorithm was used to classify the image, either go for classification problem or regression problem. But due to the advancement in deep learning algorithms, neural network replaced the manual work of feature extraction. That is, we make use of convolutional neural networks and even MLP models where automatically the features are extracted and extracted features are fed as input to the model either for classification or regression. Let's move on to the architecture, high level architecture, different parts. You have input layer, you have convolutional layer, the third part is fully connected layer and output layer. Now in fully connected layers, we have seen that we have a drawback of increasing the number of parameters in MLP model. But what do we notice here is during the extracting the features, fully connected layer will increase the number of parameters also. So to avoid that, I have replaced fully connected layer with convolutional layer for feature extraction. And fully connected layer, it is noticed that these fully connected layers will do its job very good in terms of classification. So I am using fully connected layer for classification, and the third is output prediction. Now what do you notice in this image is we are building a convolutional neural network which will classify into two classes. The given an image will be classified as either 3 or 7. So the first step is feed the raw image to the convolutional layer. The image passes through the CNN layers. You can see we have 3 layers here. And what do you notice here is as I am passing through the layers, the dimensions of the image are getting shrinked and the feature maps are increasing. Now what are these feature maps? This CNN layer, the first CNN layer will detect the patterns of this image and extract the features which are called as feature maps. Now these feature maps which are given as input to the second convolutional layer will extract features from this as well as detect the patterns and so on. So these feature maps are nothing but what? The features which are detected and the detected patterns as well as the extracted features. Now once the features which are attained at the output of your convolutional layer, they are flattened. This flattened feature vector is fed to a fully connected layer to classify the extracted features of images. And finally, the neural network will fire the node that will represent the correct prediction of the image. This is what happens in convolutional layer where we have feature maps. So as we move on through the convolutional layers, the number of feature maps increases, but the dimensions of the image gets reduced. So let us have a closer look at the feature extraction process. You can see here that this image is broken into smaller images. This is just a visual representation of having feature extraction processes in CNN. But generally speaking, CNN will not break the image into pieces. Instead, it will extract the meaningful features which will separate the object from other images in the training set and stack these one after the other in the form of vector. So when we move on to the closer look at the classification, let us take the same example where different smaller images were extracted. That is, the image was broken into smaller images. And when we look into the first feature, it either looks like 3 or looks like 7 or maybe 2 also. So as MLP model is having confusion between 3, 7 or even 2 has got introduced. So it will move on to check for the second feature. And when I look into the second feature, it is definitely not 7 because of the curve present here. And it tries to take the third feature and so on. And this process continues till the model what we have designed is confident that the image is digit 3. So this is how classification feature extraction is carried out in convolutional neural networks. So in the next session, we will talk about basic components of CNN. Thank you.